Welcome. In today's video I'm gonna teach you everything I know about slices in Go. We'll also stop a little bit near array, but only a little bit. So let's start. About arrays. Generally, we're not gonna stop here, just I assume you know more or less what array is. Like this is an example, how to use them, for example, syntax like here, and just how to invoke it. I'm not gonna stop here. I think everything's more or less clear. Like, what's the biggest problem with arrays generally? Why do we have such a thing as dynamic arrays in all of programming languages I know? For example, like in C++, I may be wrong, but they call it vectors. Probably no. Please fix me. I've not worked yet with C++ or C. But for example, in Rust we have vectors, in Go we have slice for such tasks, in Python we have list and so on. Like, don't remember by heart about C#, Java, like other popular languages, but all of them have such a thing as a dynamic array. So what's the problem when we work with usual array? We can't expand dynamically usual array. It's static. For example, you see where we declare it, we put all of like data here right now when we declare it. So we can't dynamically add a new element. We simply can't do it. We can only modify its elements by its syntax. Like for example here, yeah, we modify index like 0, the first element. The same like, for example, if we need like to modify like third element and like so on. I think you got it. I think it's clear here. And because in real tasks we always or almost always need to expand our array, we need it to grow. So for such tasks we have like in Go in particular we have slices. So what a slice is? I'm talking about Go, but generally more or less the same like structure pattern is used like in any programming languages. For example, in Rust, as far as I know, it's more or less the same. So what is slice under the hood? Under the hood, slice is a special data structure which contains three elements. Pointer. So under the hood, slice uses array. It's really important to understand because slice itself doesn't contain any data. Slice just has a pointer on the underlying array length. So like second parameter, so how many elements inside of our slice, I mean which we use under the hood, we have, and capacity, so how many elements we can put before resizing. For us, as for programmers, we don't really see such things, but this is really important to understand it. On the one hand, to use slices like with maximum efficiency, and on the other hand, on job interviews, they always ask. I'm sure 100% that like and at any job interview, whatever you have, whichever you have, they always ask you about slice under the hood. Why, for example, if we add a new element in slice, we don't see changes outside unless we return it, and so on. Okay, let's start with simple things, how it works. In Go, slice by default is a value type. What does it mean? If we pass it and don't return, and we add a new element, we don't see any changes outside. We're gonna break it down a little bit later, but we can modify its underlying array directly and it works. For example, our first example here, when we modify slice, we receive slice here, we modify the first element, and in this case we're gonna see the changes. Why? Because, as I already mentioned, slice uses array under the hood, and because here we don't change slice, we change its underlying array here. So like the first element was, as I remember, like 0, for example, and now it's 100. So this is how it works. I think it's clear, actually, yes, that you don't need to return a slice if you need to change, modify some of its elements. It's fine. Then a next case, the most tricky, they always ask you about it at your job interview, so just, yeah, this is really important to know. And like for real situation, this is also important for you not to be confused why, for example, you see no changes here. When you pass by value, yes, I already have a big lesson about pointers. It's a little bit longer that it was a little bit longer that I had been planned, but anyway, if you know this topic, you understand like that because slice is a value type and we pass it by value. So how it works? We add a new element here in the underlined array, but we're not gonna see any changes here. By the way, let me launch it just for you to illustrate all of it. Yeah, this is our first example with array when we modify. So inside of the helper function is 99, we modified, but outside it's still the same, 1, 2, 3. Actually, yes, as it was. Because with array it's clear, it's static, it's a value type, so we see no changes. If we used a pointer here, we would see the changes, but not in this case. So like with the second example, yes, as I just told you, we see the changes like 1, 2, 3. Yes, like because when we modified original slice like was 1, 2, 3, we modified with like the first element, so this is 100, and then outside of the function we see the result here. Yes, you see 100 to 3. Yeah, this is clear. I think this is how it works, how it's supposed to be. So we can change any of its elements, it works fine, and we don't need to return here or use a pointer. But when we add a new element, this is more tricky, actually. You will ask, but we add a new element into the underlying array, right? So why don't we see the changes here? Because like if we still use under the hood the same array, like here with this slice and with this slice here, why don't we see any changes? So there are two problems here. First of all, if we exceed a capacity of our slice, we need to resize it. I'm not gonna stop on it now. It's like it will be later, but like just keep it in mind, it also might be a problem. And the second problem, also a little bit tricky, because as I already mentioned, slice has pointer, length and capacity. So when we add a new element here, we change our slice capacity. For example, I apologize, length. So for example, it was 3, now it's 4. Like just in series, some abstract example, yes. But here, like in our slice here, outside of it, this is still length 3. And even though physically our underlying array like grew a little bit, so it has one more element, but because our slice here doesn't know about it, it has no idea, we don't see the changes. So we still see the same array, even though our array has one more element, we don't see it, because for us here it's just the same like array, the same elements. So this is why For example, yes, you see that inside on the function, like our slice, our underline array is 0004, but here this is just outside still 000, so we don't see a new element. This is the most tricky thing about slice, because by default this is a value type, and they always ask you about this at your job interview. So just, yes, you need to know it, keep it in mind. And anyway, it's really important when you work with it in real life on your own project, or on the customer projects. So you just need to know it. So how to solve this problem? There are two ways. First way, as we already investigated in our pointer lessons, we need to return like a slice here. If we modify and return our slice, this case we'll see our changes. I mean a new element, because how it works. We receive a slice here, so we copy its pointer, length, and capacity. We modify its element, and we append a new element here, and we return. This is the most important moment. So again, we copy it from there to here, and in this case we see our changes. Everything is fine, everything works as we just expect. You can see it here. 1 second, where it was for inside. Yeah, so this is like original slice in here inside function. Then we add a new element, then we return here. And because, yes, you see, this is the pivotal moment here. Because even though it seems like the same slice, but it's not the same. They're already different. This is a different copy, so its length different. For example, was 3 and now it's 4. So this is why we see changes. It reflects our underlying array changes. So everything is clear. Yes, so original value 000, then we changed it and also add a new element, and we see it outside of the function. Probably yes, it would be a little bit better if I call it, for example, modified slice, and that we declare it. Yeah, sure. And this we use this slice just for you to understand, yes, that this and this, they're different, they're not the same. Even if we reassign as it was before, yes, they're still different. So this is really important to keep it in mind. And the last way to do it, if you pass slice by pointer, again, yes, remember our lesson about pointers, we don't need to return. We exactly modify the same object instance, we directly modify the same slice. So this is the last example, original slice 1 to 3, then we add one more element 1 to 3 4, and now you see that everything works fine. Again, everything works as expected, and we don't need to return anything. We just pass there directly its object instance, and we just, yes, print it. So this is generally everything I wanted to show you. Now a little bit about pitfalls when you work with slices. In Go, generally, in any, it's applicable to any programming language I know, I've ever heard, seen, and so on. The first disadvantage of generally, not only a slice itself or vector or whatever, dynamic array, just generally any array, because it's their nature of arrays. If you add a new element to the end, this is how it works by default, because it is the most effective way to do it. You add a new element to the end of your array, underline, array under the hood, and this is fast. This is really fast, no problems with it, you don't need to change anything. But if you append to especially the closer to the beginning you append it, the worse performance in this case. Why? Because when, for example, you add a new element on the first position in your slice or array, doesn't matter in this case, you need to shift all of its next elements. Actually, yes, for example, here like 1, 2, 3, if you add a new element here, like just imagine, yes, we add something new here, you actually need to shift all of its elements. You see, like, it just like imagine that you because you add something here, you need to shift all of it, and this is not actually good for performance. So it's better to always to add it in the end of your array if it's possible as the last element. This is the first pitfall. And the second pitfall, when you declare your slice, you also you have a few arguments. First argument, like its length. No, sure, like I mean, first argument, sure, it's its type, but after this is length. You can read it generally in their documentation and so on. So, like, yes, usually we use it just 0. Just for our examples, we just need to fulfill it something like so. With like length 3, it means like that we just fulfill it with zeros, just to make it simpler, to make it more obvious. But usually, like, you have it like 0, and the last element, this is capacity. And this is really important to understand. They also quite often ask about it at your job interview, so you just need to know about it. No way. This is much better if you pre-allocate enough memory for your slice not to be resized. Why? Because how it works, for example, we have 3 elements here, and for capacity we add a new element here, and this is fine. Like, we don't need to resize our underlying array and recreate our slice. But if we add one more element here, for example, like this way, what happens under the hood? As a developer, you don't see it, but this is really important to understand how it works actually. And at job interview, this is also useful. You can trust me. When you exceed your capacity here, you need to resize, so recreate a new array under the hood. So, for example, we had some underlying array here in this case, and under the hood we create a new array. We copy all of like elements from our old previous array to our new array. We like remove the old array, and also we need to recreate, like create a new slice to which is gonna have a new pointer to a new underlying array, new length and new capacity. And I think it's clear that this is not good for performance generally. This is expensive for memory, this is expensive for your CPU, computations time, load, and so on. So ideally, when you always know your size, like how many elements are you gonna need, for example, like in some situation you like just use len of something, like, so you know, some abstract list. I mean, just you know, for example, in advance that it's gonna be 100 elements, and this is how you do it ideally. Usually in the most situations you know more or less how many elements you're gonna have, so you can predict it. It's much better to pre-allocate a little bit more memory than you really need, in my experience and opinion, rather than to allocate it less and then you need to again resize. recreate your array and slice, which is not so good. So like, yes, keep it just in mind. This is also the pivotal moment here. In some situations, you may even consider to use alternative data structures, for example, linked list, but there is a video from C++ creator, and he really doesn't recommend to use any data structures generally, except like vector, so slice in our case, unless you can prove like that your solution with a list and or map, for example, is better. Something like this. And the last thing I'd like to show you is just a benchmark, like just you can find it on my GitHub repository, not a big deal. So generally, as you see, the performance is nearly identical. So the option with like modify by pointer is a little bit slightly like worse than with pass and return by value. I'm actually surprised here, and if you remember my pointer lesson, like you remember that in that case pointers were always faster. But you see, as I mentioned there, it's not so simple, and yes, like generally like pointer is a little bit slower, like sometimes occupies a little bit more memory. So yes, I just assume that it happens because on the one hand slice is not a big structure, data structure is quite cheap to copy, just pointer, length and capacity arguments. We don't need to copy the underlying array on the one hand, and on the other hand, because again, just we have garbage collector in Go and we pay a price for this. This is not this is not free, not for free. So yes, like it consumes more memory, like it doesn't work so fast as when we pass by pointers, as in such languages as C, C++, Rust, Zeek, and so on, which or Swift, for example, yeah, from also a very good modern language, like just the languages I mean which don't have garbage collector. So it is. I hope it was interesting. I hope it wasn't so long as my first lesson about pointers. So I hope you enjoyed the video. If you liked it, please give it a like, subscribe to my channel, ring the bell, and hope to see you soon again. Bye.